So here's question 73. You've got a tennis ball of mass 57 grams held above a basketball of mass 590 grams with their centers vertically aligned. Both balls are released from rest and fall for a distance of 1.2 meters. Find the magnitude of their downward velocity with which the ball reaches the ground. All right, so for part A, just using kinematics, you could also use energy. V final squared equals V initial squared plus 2A times delta x. Plugging in negative 10 for gravity and the height is falling downward 1.2 meters, you can very quickly calculate they're going to hit the ground at 4.9 meters per second. That is the answer to part A. Now, the second part is much more interesting. They undergo an elastic collision. So when the basketball hits the ground, it's going to bounce back upward at 4.9, but the tennis ball is still moving downward at 4.9. I drew these separately just so you can sort of visualize it. To do elastic collisions, we could do the simultaneous equations with conservation of momentum and conservation of kinetic energy, but I'm going to do the velocity of the center of mass because it's just so much easier. Plugging that in real quick, velocity of center of mass is total momentum divided by total mass. In this case, the center of mass is going to be moving upward at 4.04 meters per second. At this point, you could use logic and figure out how fast the tennis ball is approaching the center of mass, and then figure out how fast it'd be moving away from it. Remember, that's the same thing. Or I'm going to cheat and use, or not cheat, but use the quick formula, which is the final velocity of object 2 after the collision is 2 times the velocity center of mass minus its initial velocity. In this case, our center of mass is moving at 4.04. Initial velocity of the tennis ball is negative 4.9. And if we solve that, we'll discover that its final velocity is about 13 meters per second upward, which means the ball is moving faster than either object was moving before the collision. That can happen in an elastic collision. Finally, though, we need to find the height to which it goes. Sorry, that should be 12.9. Drop the 4 here. And solving it, then, we can quickly plug this in. And if we do so, you'll discover that the height that it goes to at the very end should be about 8.45 meters above the ground, which is higher than the height that you dropped the 2 to begin with. Good luck!